Good morning, ladies and gentlemen. Welcome back to Katsina State Senior Secondary School's online connect, powered by Exponential Computers. Physics lesson for SS1 students, week 8. I, the presenter, Ismail Baraya. So, for the week 8 or the 8th week of physics lesson or physics class to the SS1 students are here. That is, explain acceleration due to gravity, express expression for acceleration due to gravity. So also the example of acceleration due to gravity, and the last one is the shape and dimension of the earth. So for the first content, that is the acceleration due to gravity. So normally when we say acceleration, before we even go further, we are talking about the change in velocity with time. That is the definition of acceleration. That is what we mean by acceleration, the change in velocity divided by time or with time. That is how acceleration used to work. So we are talking about acceleration due to gravity. That is that change of velocity with time, but due to the acceleration due to gravity. That is our heading. So when we say acceleration due to gravity, you are talking about the gravity, the force of gravitational field or gravitational force that is absorbing a particle to come back toward the center of the earth, or to bring that object or that particle to come back to that earth or to the earth. So normally is the one of the best scientists, that is the Sir Isaac Newton. So he is the one that come up with the theory of gravitation after he witnessed the fall of an apple on his head. So Sir Isaac Newton, he is a physicist scientist. So he discovered that when he was sitting on a bench or something like that, so under a tree of an apple, so an apple tried to fall down. So that apple, as it is trying to fall down, he noticed something. He noticed that what is that force that is absorbing that apple to come down to the ground? Why not that apple to go off in the sky or to stay on the space? But that apple come down. That is why he discovered the gravitation. That is why he started discovering the gravitational force or the gravity. So Sir Isaac Newton is the one that discovered the gravitation or the gravitational field or force or gravity. So acceleration due to gravity is the increased speed of an object as it approaches the ground under the influence of gravity. So you see, it is the increasing. I told you that apple, as it is trying to come down towards the center of the earth. So the increasing the speed that is coming with it, it will keep increasing as that apple is coming down to the earth, or I mean to the ground. As the speed will be increasing, the apple, or let's say of an object or particle, as it is trying to come down to the ground, to the center of the earth, the speed of that object will keep increasing, at the end of the day that apple will come down with a heavy speed on the ground and or on the earth. So you see, it is an increasing, the speed will be increasing from the starting point of that apple. As it is trying to come down, the speed of that apple will keep increasing. It will come down heavier or heavy with the speed that is coming with it. It will keep increasing. So that increasing, it is called the acceleration due to gravity. That is what we mean by acceleration due to gravity. So this acceleration due to gravity occur as a result of the earth's largest mass, which attract objects to it due to the force of gravity. So you see, it is due to the earth's mass, the earth of the mass. It is that one that is bringing that object to come down to the ground. So if you look at this diagram here, it's trying to explain for the acceleration due to gravity. As the apple is trying to come down, the speed of that apple will keep increasing, until it reaches the center of the earth, or the ground. So you see, that increasing of that space as that object it is doing, or that apple is doing, it is acceleration due to gravity. That is how the speed will keep increasing, so it is acceleration due to gravity. So that is it. So acceleration due to gravity is the increased speed of an object as it approaches the ground under the influence of gravity. So that is the acceleration due to gravity. So here we are to talk about the expression for acceleration due to gravity. So it is a value. It is a constant value. Acceleration due to gravity has a constant value. So that constant value, it is the value near the surface of the earth. That is 9.8 meter per second square. So this 9.8 meter per second square is a constant value for acceleration due to gravity. And also it is alphabetically, that is the small alphabet G. So this small alphabet G stands for the acceleration due to gravity. So wherever you see this small G in physics, is talking about the acceleration due to gravity, and it has a constant value of 9.8 meter per second square. Or if you can do the approximation, that is, you will increase from 9.8, you will just make it 10 meter per second square. So whether you see 10 meter per second square or 9.8 meter per second square, is a constant value for acceleration due to gravity. And when we say constant value, we mean that that value is not changing. It will remain constant. It is not changing. So this is the value for acceleration due to gravity. So, and also this acceleration due to gravity has a formula, that is small g is equal to capital G m all over r square, where the g is the gravitational constant. So also this g also, it is a gravitational constant. So that means that it has a constant value and it is not changing. And also this is the m, that is the capital M, that is the mass of the object, and also the r, that is the radius of the object. So this is the formula for acceleration due to gravity. So when a body is released from a height so that it falls towards the center of the earth, g is positive. So you see, as it is coming towards the center of the earth, the g is positive. But when a body is thrown offward movement, g is negative. So you see, if you throw something upward, that is up straight in the let's say in the sky, so you see, you are going against the acceleration due to gravity. You are going against the gravitational field or the gravitational force, because you are trying to go up. But normally acceleration due or gravitational force is trying to bring object down. So you see, you will go off against it. That means that the g will be negative. But when it is coming down, you see, but normally the acceleration due to gravity used to make things or object or particle to come down towards the center of the earth. So that means that it is positive. So this is for the expression for acceleration due to gravity. So here is the example for acceleration due to gravity, and it says that calculating the acceleration due to gravity on the surface of the earth. Mass of the earth is equal to 5.97 times 10 to the power of 24 kilogram. So you see that mass is given, and the radius of the earth is 6.376 times 10 to the power of 6 m. That is the meter. And the universal gravitational constant, and that is the capital G. So this G, the gravitational constant, and also has a value of 6.67408 times 10 to the power of minus 11 meter cube per kilogram per second square. So let's go if we can be able to solve this acceleration due to gravity, because we know the formula of calculating acceleration due to gravity. So let's put the formula and see. So normally our formula for calculating acceleration due to gravity is equal to small g is equal to capital G m r square. So this is the formula for calculating acceleration due to gravity. And also we have our mass and the radius, they are given, but this capital G, mark you, it is a constant value. It is not changing, and it is called universal gravitational constant. It has a constant value, it is not changing, and the mass is given and the radius is given. So let's put the formula and see. And this capital G, we will just put the constant value of the capital G, that is the universal gravitational constant, which have 6.674808 times 10 to the power of minus 11. That is the value of the G, of whom bracket the value of M, which is given, that is the 5.979 times 10 to the power of 24 divided by 6.376 times 10 to the power of 6, but it is in square because it is the R, that is the R. So if then let's solve this R, the radius, because it is in square, so let's expand it. Then the second step, we just put our constant value of the G, that is the 6.67808 times 10 to the power of minus 11 open bracket 5.979 times 10 to the power of 24 open bracket 4.065 times 10 to the power of 13. So the value of the radius of the R, it is in square. That is what we just do, we just square it. That is what we just multiply, the value of the R times the value of the R. That is where we have this 4.06 times 10 to the power of 13. That is the value of the squaring of the radius. So let's just divide the mass and the radius and just see. If you are to just divide this 5.979 times 10 to the power of 24 divided by 4.065 times 10 to the power of 13, and if we divide it, then we will just having a value of this G. We are just going with it, this because it is a constant value, that is 6.6708 times 10 to the power of minus 11 times. That is, we just divide by the mass and the R. That is the value of the mass and divided by the value of the radius. That is why we have a value of 1.470 times 10 to the power of minus 11. This is the value that we get after we do the division. So, and lastly, we are just to multiply the gravitational constant with the value that we have. So if we just multiply the 6.6708 times 10 to the power of minus 11 times 1.470 times 10 to the power of minus 11, then we will end up with 9.80665 meter per second square. So acceleration due to gravity, it is equal to small g is equal to 9.80665 meter per second square. So this is how the value of acceleration due to gravity used to find. That is the acceleration due to gravity, that is the small g, and this is the constant value for acceleration due to gravity. So wherever you see acceleration due to gravity, you will think of this small g, that is the value that have a 9.8. And I told you can approximate it to make it 10, and if it is 10, it is only 10 meter per second square. So this is about calculating of acceleration due to gravity. So for the last contents of the physics class or physics lesson to this week is the shape and dimension of the Earth. So the Earth is one of the 9 planets. So normally also Earth is one of those 9 planets that we have in the universe, in the solar system. So it is a spherical in shape. So it is spherical in shape. So you see, normally as it is not a exact complete cycle. So normally as is not a exact cycle. So when we say something exact cycle, we mean it is a circular in shape. So as is not circular in shape, it is spherical. So normally as it is but it almost look like a circular in shape. So as is not circular in shape, it is a spherical in shape. So it is also divided into 2 hemispheres. So normally as is divided into 2 hemispheres. That is the northern and the southern hemisphere. So these are the 2 dimensions of the Earth. So there are major 2 types of lines that run through the earth. So this the line that divided the earth are only these two. That is include the latitude line and the longitude line. So these two lines are the ones that divided the earth. That is the one that they divided the dimensions the earth. That is the longitude line and the latitude line. So let's go and see if you can identify the longitude and the latitude lines. So here it is like an earth here. So sorry. So here it is like an earth. So if you look at this one, the one in the left hand side, the earth on the left hand side, you will see that the line are they are horizontally, like they are horizontally. If you look at it normally, the lines they are in horizontal row, they are in the horizontal. So this line of the horizontal, the one that are in horizontal, they are called the line of latitude. So the line of the latitude, the one that divided the earth in a horizontal line, is called the latitude line. So if you look at the one in the right hand side, you will see that like they are in a vertical line. So you see the ones that are in vertical line, they are called the longitude line. So you see, and also the line of the meridian, that is the prime meridian. So you see these two lines, they are the ones that divided the earth. So let's check this note and see. This note is said the latitude line are imaginary lines running from the east to the west. So you see the line of latitude, it is running to the east to the west. So you see that is the one in horizontal. It is talking about the one of the latitude. So this means that they increase toward the north or the south. So you see the increase toward the north or the south, the increase. So you see the line of the latitude, like it is in like a vertically, it is running from the east to the west. So this is about the line of the latitude. But the line of the longitude also, it is imaginary line running from the north pole to the south pole. And when we see something like that, we are talking about like it is in a vertical. So you see this one is talking about the longitude line. So you see and the increase toward the east to the west. So also the increase toward the east to the west. So you see this is about those two lines that divided the earth into two, that is the longitude line and the latitude line. And however, the earth has a radius of approximate 6,400 kilometers. So this value is a value of the radius of the earth, that is the 6,400 kilometer. This is the value for the radius of the earth. So I think this is the end of this week lesson or class to the SS1 students. So I wish you best of luck.